Hello students. Uh, Today I am going to discuss another problem on fluid mechanics based on surface tension and surface energy. This question has been asked two times. One is in AIEEE 2012 and one again it has been asked in JEE Mains 2014. So this is a very important question on surface tension and surface energy. So the question is, a large number of droplets, each of radius small r, coalesce, that means they merge to form a bigger drop of radius capital R. তার মানে আমার হাতত বহুত কেইটা কি আছে স্মল ড্রপ আছে নাম্বার অফ ড্রপলেটস ওকে এই গোটেই কেইটা ড্ৰপলেটছ অফ ইউনিফৰ্ম সাইজ একে সাইজৰ হয় যাৰ ৰেডিয়াছটো কিমান বুলি কৈছে the radius is r. Okay, radius is r. Now they will coalesce or they will merge. Okay, they will merge to form a bigger drop. They will merge to form a bigger drop which will have a radius of capital R. Okay, an engineer designs a machine so that the energy released in this process is converted into the kinetic energy of the drop. Now the energy will be released in this process. Why? As we know, when these are the small droplets, right, the surface energy will be more here, because if we add the surface area of surface energy is proportional to surface area, is it? Because if the molecules will have more surface area, then there will be more number of molecules, right? Now if we add all the surface area of these, let there be n droplets, surface area of all these n droplets, then the surface area of these n droplets will be summation of surface area of n droplets will be more than the droplet of this bigger drop. Okay, so from this surface we can say surface area, it is obvious surface area of n droplets will be more than surface area of single bigger drop of radius capital R. Okay, that means the surface energy of n droplets is greater than surface energy of bigger drop. Okay, now when these n droplets merge to form a bigger drop, that means there is a decrease in the energy, in the surface energy. That means decrease in the potential energy of the surface. Okay, potential energy to komi jabo yate. So এই যিখিনি energy komi gol, the decreased energy that will be released, okay, in this process. The decreased energy will be released in this process. Now the question says, this decrease in energy which has been released in this process, that is converted to kinetic energy of the drop. Okay, kinetic energy of this bigger drop. That means this decrease in energy, that means energy released, will be used in the motion of this bigger drop. Okay, that means kinetic energy of the bigger drop. If we let me say, let me tell you that this released kinetic energy, released potential energy of the surface will be equal to half mv square. Okay, so let kinetic energy of the bigger drop is equal to half mv square, where m is the mass of the bigger drop and v is the velocity of the bigger drop. Bigger drop means of radius capital R. Is it? Now the question says, what is the velocity of the drop? Given here, the surface tension is T and rho is the density of the drop. Okay. So from all these concepts, okay, we can write that decreased energy that is released in this process is equal to kinetic energy of the bigger drop, half mv square. Okay. Now, what will be the decreased energy? For that, we need to find out first the decreased in energy. So initially, what we have n number of droplets, right? Initially, we have n number of droplets. We don't know how much number of droplets are there. A large number of droplets. In the question it says, so of radius smaller, it will form a bigger drop of radius capital R. So in this process, what will remain same? Always the quantity of matter. That is, the volume will remain same. From that, one equation we will get, that is n into volume of a single droplets, and we have assumed that there is n number of molecules, n number of drops, n into 4 by 3 pi small r cube, that will be equal to 4 by volume of the bigger drop, 4 by 3 pi capital R cube. From this, we can find out the number of such small droplets which will form this bigger drop of radius capital R. So from this, we will have the value of n as 4 by 3 got cancels, pi got cancels, n is equal to your r cube by capital R cube by small r cube. So this will be using in the next equation. Okay. So from this, what will be the surface energy of this? This is your initial condition. This is your initial. This is your final state. Okay, final state. In the initial state, what will be the energy? Surface energy. As we all know that surface energy is defined as the surface energy, total surface energy of the surface per unit area, and that is also equal to the surface tension. So if we multiply the surface energy with the area of the molecules, not molecules, area of these droplets, surface area of these droplets, then we will get the total surface energy. Okay. Now, since surface energy is equal to surface tension, the surface tension is given as T, so we will multiply this surface tension, TET, surface area. So there are n number of molecules, so n into 4 pi small r square. This will be the total surface area. In the initial state, this will be your surface energy. Okay, this will be more than this surface energy. In the final state, the surface energy final will be equal to T into 4 pi capital R square. Now if we subtract this we final energy from the initial energy, we will get the decrease in energy. That is, decrease in energy is equal to surface energy initial minus surface energy final. Okay, so this will be equal to the T into n into 4 pi r square minus T into 4 pi capital R square. If we put the value of n here, r cube by small r cube into 4 pi r square minus T into 4 pi capital R square. Now if we do this, what we will get is this r square and this r cube is r. Okay, so we will left with T into 4 pi capital R cube by small r minus T into 4 pi capital R square. Okay, so if we take it common, 4 pi r square, if we take it common, 4 pi r square T we can take it common. Okay, then we will be left with r by small r minus 1. Okay, r by small r minus 1. 4 pi r cube r square. Then this will be equal to your decrease in energy, right? That is your energy released. Now this energy released will be equal to half mv square. Okay, half mv square of the bigger drop is equal to 4 pi r square T r by small r minus 1. Okay, 4 pi r square, this is 1, 4 pi r square, take it common, to r square. So what will be the mass of this? If density of the droplets is rho, then rho into volume, density into volume will give you the mass 4 by 3 pi capital R cube, okay, into v square is equal to 4 pi r square T into r by r minus 1. Is it? Okay. Then from this 4 will got cancelled. This pi will got cancelled. This r and this r, there will be r left behind. V square, this is rho, so v square will be equal to T, this will be 6T by rho r by small r minus 1. Okay, now this can be written as 6T by rho 1 by r minus 1 by capital R. Okay, so velocity will be equal to, so the velocity of the bigger drop will be equal to v equal to root over 6T by rho 1 by r minus 1 by capital R. So this is the velocity of the bigger drop if the energy released is used as a kinetic energy of the bigger drop. Okay, so what will be our answer? The answer is this one, 6T by rho 1 by r minus 1 equal to, it is root over. So this is your answer, correct answer. I hope all of you have understood. So if you have any question, then feel free to ask me. Thank you.